Everybody. I'm Joshua Parr, and this is Mankind in Training. I have a quick demonstration for you involving systems of linear equations. Let me just share my screen real quick. So normally, solving systems of linear equations it takes forever. It really does. And like if you have a ton of different constraints, it just gets super duper tedious. Graphing makes it a little bit faster, but usually by hand you're doing it with the substitution method or the elimination method. So this was a trick that I've learned. If you use the R programming language in the Tibble package, I'm going to give you there's a way you can do it without the Tibble package, I think. The first methodology doesn't necessarily require the tidyverse or any of that business. So I have a couple of sample systems of equations here that trying to find a bound, trying to find coefficients, the x, y, and the z, where it fits all of the constraints. And I wrote up a bunch of them that were like doozies on purpose to try to trip it up, and it just does it so fast. It makes very quick work of it. So these first couple I already have queued up in here. So 1 and 2, and then I'll write out the third one with you guys. So what I have here is I'm taking the linear model function, and I am finding B, and I'm using the Tibble-Tribble package in the very first example. So what I'm going to do here is, I should explain this right quick. In your x variable, you'll put what's out in front here. Same with the y and same with the z. And then you just put its equivalents in the B position. And if I run this, bam, so fast. That is wild how quick that happens, because if you've ever done this by hand, you understand all of the math that really goes into this. It is a pain. And this this blew my mind when I first seen this. I was like, no way. Man, that makes it just easy. So here's a different methodology, not involving calling Tibble specifically, where you just enter a data and data frame. The formatting's slightly different, but it's the same exact concept, and you don't it's again a 3x4 or a 4x3, or I always get confused with those. So now here's the second example. Here and here. I'm going to run it. Bam! With the quickness. 11.12 for x, 13.4 for y, and negative 12.4 for z. Fits all of the constraints. So now what I'm going to do is write in the third one. Here. So I'm going to do my x row, negative 152, 61, and negative 103. I laugh because I picked just some outrageous positions. 5, 2, -1. Yeah. Z is 47, -18, and +150. And answer column, 1, -2. Just as such. And run it. Bam! That is so fast. Oh my goodness. So this one I actually just did for the very first time. I just typed it all out, and that's exactly how you're going to do it. You don't have to do it in the order that I did, obviously. You can go and do them like equation by equation, where, well, I just happened to do them by column. And that is a quick demonstration of how you would find coefficients for linear systems of equations in R. One thing, when you go into the packages here, you have to download Tibble, which is right there. And I've since learned that Tibble is included in Tidier, I think. So I tried to get rid of it, or I was trying to update it, and it said I couldn't update it because I already had it loaded up through Tidier. So I'm not entirely certain on that fact, but it seems as if though that may be the case. But you do need to upload Tibble before you do this call here. And other than that, that is my quick demonstration for you guys here this evening. I plan to do another one very soon. Real quick run through of Power BI and how you load up a data set and how to make some visualizations with said data. But thank you for watching. It's been Mankind in Training, and I'm your host, Joshua Parr. Have a nice night, everybody.